Imagine every single human being on Earth, all 8 billion of us, somehow agreed to do one thing at the exact same time. Jump. Not a little hop, a real jump. Feet leaving the ground, arms swinging, the kind of jump you do when your team scores in the last second. 8 billion people launching themselves into the air at the exact same moment. Would the Earth move? Would we knock our own planet out of orbit? Would buildings collapse from the shockwave? It sounds like the kind of question a kid asks at the dinner table, but when physicists actually sat down and did the math, the answer turned out to be far stranger and far more interesting than anyone expected. Let us start with the jump itself. The average human weighs about 62 kilograms, and during a good jump, a person leaves the ground for roughly a third of a second, reaching a height of maybe 30 centimeters. That does not sound like much, but multiplied by 8 billion, and suddenly you are dealing with a combined human mass of about 500 billion kilograms launching off the surface simultaneously. That sounds enormous until you compare it to the thing those people are jumping off of. The Earth weighs approximately 6 times 10 to the power of 24 kilograms. To put that ratio into perspective, the total mass of every living human being compared to the mass of the Earth is roughly equivalent to the weight of a single grain of sand compared to the weight of a fully loaded cargo ship. So, when all 8 billion people jump at the same time, applying Newton's third law, every action has an equal and opposite reaction. The Earth does technically move. It shifts in the opposite direction of the jump, but the distance it moves is absurdly, almost comically small. We are talking about something on the order of 1/100th of the width of a single hydrogen atom. The Earth moves less than the smallest thing you could possibly imagine moving. If you had the most sensitive measuring instrument ever devised by humanity, you still could not detect it. The planet essentially does not notice. But here is where the question gets more interesting, because the jump is not really the problem. It is the landing. When 8 billion people come back down roughly a third of a second later, they all hit the ground at essentially the same instant. And this is where things start to get wild. When 8 billion pairs of feet slamming into the Earth's surface simultaneously would generate a combined force roughly equivalent to a moderate earthquake, somewhere around magnitude 4 to 5 on the Richter scale. But here is the critical detail that changes everything. An earthquake's power comes from the fact that it releases energy from a single concentrated fault line deep underground, sending seismic waves rippling outward through the bedrock for hundreds of kilometers. Our 8 billion person jump is the opposite. The force is spread across the entire surface of the planet, wherever people happen to be standing. And here is where the first truly surprising twist enters the picture. For this thought experiment to work, all 8 billion people need to be in the same place at the same time. You cannot have people jumping in Tokyo and people jumping in New York and expect the forces to add up. Because the Earth is round, people on opposite sides of the planet would be jumping in opposite directions relative to the Earth's center, and their forces would cancel each other out. So, for maximum impact, let us put everyone in one location. Scientists who have run this thought experiment usually pick a spot like Rhode Island in the United States, which has just barely enough area for 8 billion people to stand shoulder to shoulder. So picture it, every human being alive, crammed into one small American state, standing so close together that shoulders are touching in every direction as far as the eye can see. The entire rest of the planet is completely empty. Every city, every village, every farm, every island, abandoned. We're 8 billion people in one spot. Now everyone jumps. The ground shakes. A seismic wave radiates outward from Rhode Island through the bedrock of North America, across the ocean floors, around the planet. It is detectable on seismographs worldwide, but it is not catastrophic. The buildings in nearby cities might rattle slightly, windows might vibrate, but nothing collapses. The seismic event registers maybe as a 5 on the Richter scale, similar to the kind of earthquake that happens naturally several thousand times a year without making the news. So the jump itself is, from a geological perspective, disappointingly insignificant. But now comes the real disaster, and it has nothing to do with physics. It has everything to do with what happens after the jump. Because you now have 8 billion people standing shoulder to shoulder in Rhode Island, and they all need to get home. The entire global infrastructure is concentrated in places where nobody currently is. Every power plant, every hospital, every water treatment facility, every farm, every airport, all of it is sitting unmanned across the empty planet. The food supply chain has been completely severed. There is no running water in Rhode Island for 8 billion people. There is no sewage system designed for that capacity. There is no communication network that can handle 8 billion simultaneous phone calls to figure out how to leave. The roads out of Rhode Island can handle maybe a few 100,000 cars per day under ideal conditions. At that rate, it would take decades to evacuate everyone, and that is assuming there are even cars available and fuel to run them. Within hours, the crowd becomes a humanitarian catastrophe beyond anything in recorded history. Dehydration begins within the first day. Food runs out almost immediately. Rhode Island's grocery stores serve about 1 million people, not 8 billion. Temperatures within the densely packed crowd begin to rise from body heat alone. In summer conditions, heat stroke would begin killing people within hours. The sheer density of the crowd means that if anyone falls, they risk being trampled. Medical emergencies cannot be reached by first responders because there is no way to move through a crowd of that density. Communication systems fail under the load. Panic sets in quickly. The actual physics of the jump, the seismic wave, need the theoretical micro-movement of the Earth. All of it becomes irrelevant compared to the logistical apocalypse of putting every human in one spot. But let us push the thought experiment even further, because physicists cannot resist asking, what if we made it bigger? What if instead of jumping 30 centimeters, every human could somehow jump 30 kilometers straight up? Ignoring the obvious biological impossibility, the force of 8 billion people hitting the ground from that height would be genuinely devastating. The impact energy would approach that of a small nuclear detonation. The ground at the impact site would liquefy. A crater would form. The shockwave through the air would flatten everything for kilometers. Seismic waves would trigger actual earthquakes along nearby fault lines. A cloud of dust and debris would rise into the atmosphere. But even this apocalyptic scenario would not move the Earth in any meaningful way. The planet is simply too massive. You could drop every human being from orbit, and the Earth would absorb the impact the way an ocean absorbs a raindrop. The planet would not even change its rotation speed by a measurable amount. But here is something genuinely mind-blowing that most people do not consider. While 8 billion humans jumping cannot move the Earth is already being moved by forces far more powerful, and most people have no idea it is happening. The gravitational pull of the moon causes the Earth's surface to rise and fall by about 30 centimeters twice a day. Yes, not just the oceans. The actual solid ground beneath your feet lifts up and settles back down in a tidal cycle, and you have never once noticed. Jupiter, the largest planet in our solar system, exerts enough gravitational pull on Earth to shift our orbit slightly over thousands of years. Even the sun is not stationary. It is hurtling through the Milky Way at over 200 kilometers per second, dragging Earth and every other planet along with it in a spiraling corkscrew path through the galaxy. And the Milky Way itself is falling toward the Andromeda Galaxy at a speed of approximately 110 kilometers per second, meaning that since you started listening to this, you have traveled roughly thousands of kilometers through space without feeling a thing. So the answer to what would happen if everyone on Earth jumped at once is actually 3 answers layered on top of each other. Physically, the Earth would move an amount so small it makes the width of an atom look enormous, and it would bounce right back the instant everyone landed. Seismically, the landing would produce a detectable but unimpressive ripple equivalent to one of the thousands of minor earthquakes that happen every year. But logistically, the act of gathering everyone into one place to execute the jump would be the single greatest disaster in human history. A catastrophe not caused by the jump, but by the impossibility of putting 8 billion people somewhere and then getting them home again. The universe does not care about our grand coordinated gestures. We could organize every human into the most synchronized act of defiance against gravity ever attempted, and the Earth would respond with the cosmic equivalent of not even blinking. But the fact that we would even ask the question, that we would imagine all of humanity acting in unison, that we would run the math and chase the answer just to satisfy the curiosity, that might be the most human thing about us.